All right, hopefully you've taken some time to learn the four things that make up biotic potential and how they kind of fit together and work to make a population grow, or at least influence how a population can grow. What we're going to look at now is what are some of the things that keep a population from growing out of control. Why don't gophers take over southern Alberta? So we call those limiting factors. And these are factors that prevent a population from attaining their biotic potential. So for example, there might be too much light or too little light. Both of those can be detrimental either to a plant or even to an animal if you can't see enough, or if it's too bright and it actually can damage your eyes, or even a plant can actually even get a sunburn if there's too much or too direct of the light, or I guess the equivalent of a sunburn. It can actually damage them and they won't grow or be able to reach their potential. They won't be as healthy as they could. It could be something like not enough food, or a high number of predators that keeps the population down. Maybe not enough water. And this list could go on and on and on. Really, these limits on them could be anything that keeps them from reaching their biotic potential. So when you combine those four factors of biotic potential we talked about, anything that keeps them down or limits their survival, limits their reproduction, any of those things, limits their lifespan, all of those would be considered limiting factors that are going to keep them from reaching their maximum biotic potential. Now, some of those environmental factors are built into what we call the carrying capacity. So the carrying capacity is the maximum number of individuals of a species that can be supported by an ecosystem. So if you have a field, for example, what's the maximum number of sheep that can live in that field? If you put in too many, they're going to eat the grass right to the dirt. If you have not enough, they'll probably be very healthy because they'll have lots of food and they'll be able to reproduce more. So carrying capacity is a way of measuring or estimating how many organisms that environment could hold. Now, let me draw for you here some examples. So in that bottom, underneath carrying capacity in your notes, I just want you to look at some of these. I'm going to turn off my ugly mug here for a second so I can draw this for you. Let's draw in two graphs down here like this. And our y-axis will just be the number of individuals in the population. And the bottom of both of these is just going to be time. Okay. Now, carrying capacity we're going to show as this dotted red line. Let's say that's the maximum number of a certain species that an environment can hold. If a population grows slow enough, then as the population grows and approaches that line, their growth tends to slow because there's not as much food, there's not as much water, there's not as many breeding sites available, and so their growth slows a little bit. And populations tend to fluctuate up and down, maybe more or less depending on the season or the time of year, but they tend to fluctuate around that carrying capacity and maintain a relatively stable population. If they were to grow really, really rapidly though, like I think I mentioned before in class, that island that had the elk brought to it, or the reindeer, I can't remember exactly what it were, but they were brought to this island where they had no predators or anything on them. If their population grows too quickly, they can very rapidly exceed their carrying capacity. And since they go so far above their carrying capacity, there's no food, or very, very little food. Disease can run rampant through the population, and it leads to usually a very rapid die-off afterwards because they just exceeded that carrying capacity far too much, far too quickly, and the population's going to drop back off. Now, it may drop all the way down to nothing, where the population just completely dies off in extreme cases, or it may just drop down to a point where it can then start to come back up, hopefully then at a slower rate, but depending on the biotic potential and the other factors, there can be some fairly dramatic swings in a population like this. So that's carrying capacity, looking at how many of an individual or a species could live within that certain area. Okay? All right, I'll turn this back off. All right. Now, some other things that influence how species perform are some laws we're going to talk about. And the first one is called the law of the minimum. And it states that the nutrient in the least supply is the one that limits growth. So if you think about this garden, kind of an example here, let's say that this soil is very rich in almost everything that the plant needs. It has potassium, it has phosphorus, it has sulfur, it has water, all of those nutrients that it needs, except it's really low in nitrogen. Well, even though all of those other things are perfect, are great, the law of the minimum states that that plant will be held back because nitrogen is low. There's not enough of that minimum thing. A human example would be if your diet is high in calcium and everything, but you're really low in vitamin D. You're not outside spending time in the sunshine so your body can synthesize vitamin D, and you're not getting enough of it in your diet. That means that would be that one nutrient that's low is going to be the thing holding you back. So that's what the law of the minimum is trying to say. Even if everything else is perfect, if you have one thing that you don't have enough of, that's what's going to hold you back. If you have a perfect diet but you don't drink enough water, that's going to hold you back. Whatever that one low thing is. Okay? Now, the law of tolerance says that in just about everything, we have a range where we are happy. So, for example, here, this is fish population in temperature. So as we go from low temperature to high temperature over here, you can see there's this area here where there's a very, very, they call it the optimum range. The population grows and is doing very, very well. As we go lower, though, you see it moves into this zone of physiological stress, an area where the population isn't growing as well as it should. And you can see how it's starting to affect them. The waters is too cold for them to do very well. They still survive, but not as well. And then if you go really low, there's a zone of intolerance where the fish can't survive at all. The same thing on the high end. As the temperatures get higher, you'll see that their numbers drop off to an area where there's a very low population or a zone of stress, and then eventually a really high temperature where they're just not going to survive at all in that kind of a temperature. So this is what we're looking at here is how does this range affect them? And this goes for almost anything. You know, sometimes you may have heard people or your parents say moderation in all things. That's kind of what we're getting at here. I mean, even human beings, if you want to think about water, which we absolutely need to drink, if we drink too little water, we're going to die. We have an ideal, which most people say is about 2 liters or 8 cups of water a day. But you can, on the far end, you can actually drink yourself to death with water. Now, it doesn't necessarily mean quantity, but it actually has to be a really, really, really high quantity in a very short period of time. Like if you decided to try to drink 5 gallons of water in under an hour, you can actually dilute your body, your blood, and your chemistry so much that your brain and your organs start to shut down because you've diluted everything so much. It's called hyperhidrosis. But even in something so necessary for us like water, we have a zone where we want to be. Too much water and we can die. Too little water and we're not happy either. We can run into the same thing with things like oxygen, right? Our bodies are designed to live at about 19 to 20% oxygen. That's what our planet is. If we suddenly tried to live at 100% oxygen, there's some things in our body that actually don't work very well if we get too high. And if we get too low, it's also not great for our bodies, obviously, because we don't have enough oxygen to provide what we need. So in anything just about that you can think of, there is a range where we have an optimum value that's like the perfect amount, and then there's too much, and that can be bad, and then there's too little, and that can also be bad. That's the law of tolerance, that there's a range there that we fit into somewhere. Okay? All right. Now, another thing that affects population is population density. So if you look at this picture here, you'll see this. This is a map from 2015 that kind of demonstrates population density, where we have lots of population and where we have very little. For example, you can see the upper part of Africa has very little, where it's kind of very desert-like. You can see areas just above India where you're into the Himalayan mountains, there's very little. But there's also areas that are very dense, like Europe, like India, like China, like the eastern part of the United States, populations that are quite dense, where there's a lot of people living together in a very small space. Okay? Now, that leads to some different factors. And the first one you need to know is what we call density-independent factors. These are factors in an ecosystem that affect members of a population regardless of population density. It doesn't matter if there's 1 of you in an area or 1,000 of you in the area, this will still affect you roughly the same. So examples of this would be things like a flood, right? Having more people there isn't going to make the flood any different. It's just a flood. Now, we're not talking about the people causing the flood, because having more people in an area may affect a flood if we've done other things. I'm just talking about the flood itself. The flood, if it's already happening, won't be any better or won't be any worse if there's 1 person or if there's 1,000 people. It stays the same. The same roughly with a fire, other than if you have more houses, there may be more to burn. But the fire isn't going to burn the forest any different if there's 1 deer in the forest or if there's 1,000 deer in the forest. The fire is just going to burn because it's going to burn. Okay, spraying with pesticides. That pesticide is going to have the same effect, or at least the same percentage of killing off a pest, whether there's 1 or whether there's 1,000 of them there. Changes in temperature or climate. Again, we're not talking about human causing climate. We're just saying if there was a change in temperature for some reason, it won't matter if there's 50 polar bears or if there's 2. That's going to have the same rough effect. Or destruction of habitat or drought. These are all things, again, we're not talking about human caused, like our population numbers causing this. We're just talking about if the habitat was already destroyed, it's not going to have more of an effect or less of an effect on that population if there's 1 of them or if there's 1,000. It'll have the same effect. Their habitat is still destroyed. Same with a drought. Now, the other type is what we call density-dependent factors. And these are things that actually do change depending on how much of a population there is. So a food shortage would be a good example. If there is a food shortage, that's going to affect you differently if there's 1 of you or if there's 1,000 of you. Right? That will be a stronger effect on a bigger population than it will be on a smaller population. If there's competition for mates, the bigger that population is, probably the more intense the competition is going to be, versus if there's only 4, that competition might be lower. Or it might be higher, actually, even, but it's going to change depending on that density. A disease is a good example. So if you've got a microorganism or a parasite, or in the case we're living right now, a virus, the transmission of that disease, the spread of that disease is going to happen a lot faster in a dense population than it is in a really spread out population. If you live out on a farm in past Mountain View, kind of in the boondocks, and you never really see many people other than to go get groceries or the mail or something, the chance of you getting a virus or a disease that's spreading is probably much lower. If you live in China or Japan in a apartment complex, in a city where the subways are so packed that they actually have people whose job it is to wear white gloves and shove the people into the subway cars so the doors can close, you can see in that kind of an environment a disease, a microorganism, or parasite, something like that can spread much more rapidly through a population because they're so much closer together. Introduction of an exotic species. Obviously, the more dense the population, it's going to have a larger impact on the environment. And then increased predation. So if you've got a large population of predators, that's going to affect you differently than a small population of predators. And even as prey, if you have a large population of prey, that might have a different attraction to predators, or maybe it's a better defense, but it will have some kind of an impact on how predators interact with that population, whether there's a lot of them or whether there's just very few of them. So I know that's a little bit tricky distinction between those two. Density independent really don't matter how many are there, it's going to happen either way. Density dependent are absolutely going to be affected by the population numbers. And you could probably argue some of those things that we talked about either way. And on a test, if you could argue your position to explain to me why you would say it was density dependent or why it was density independent, I would probably give you the marks as long as you've got a good reasoned argument. Because I could think of some situations where some of these could move from one of these to the other. So that's it for this lesson. If you have any questions or problems with any of this, let me know. Keep working through. If you want more information, go to the textbook. Try the practice problems. If you have any problems or questions, let me know.